What kinds of devices are getting compromised or used to launch these attacks?
They're coming from
Internet of
they're
Things,
coming from
refrigerators.
everywhere. Yeah, exactly.
Is it fair to say that companies are being attacked by washing machines, fridges, and all these kinds of weird devices that we're putting online these days?
I see a cartoon or a movie in this, right? I mean, you got wash machines coming at you, and fridges coming at you, but it's true, right? Anywhere that they have connectivity and you have the ability to launch any type of scripts, it can be done in any device. And we don't protect those things. We don't think about it. So,
And there are more and more devices out there that can be attacked or used as part of the botnet. And this is why we need solutions like what Cisco and Radware are doing.
Wouldn't it be cool if you could use a crypto challenge algorithm to make those devices so busy that they can't attack you anymore?
That's clever.
And that's what we do that.
it's called fighting back.
Yeah, man. Absolutely. It's called fighting back.
Everyone, David Bombal back with two very special guests. Tim, Mike, welcome.
Thank you.
So,
Thank you, David.
I gotta hit you with this right off the bat. There are no DDoS attacks in 2025, right?
Certainly not.
Good, I'm lying. April Fool!
What we see on the screen sitting in front of me, showing a live map of all the DDoS attacks across the world, looks like something out of a bad Star Wars movie. Yes, it's not only that there are attacks. What we've been really challenged with Cisco and Radware together as partners is to go and deliver kind of how you keep up and get detection to see the attacks that are here today, but even more, how you deal with the constant evolving nature of what the attacks are. Russo-Ukrainian conflict brought a whole new attack economy. It brought a whole new, way to abuse networks with layer 7 attacks, all these things. So, what Tim and I do every day is to partner to figure out, how do we see that it's happening and what can we do at scale?
So on the map that you've got, right, what are we seeing? Can you kind of talk us through what we're seeing?
Yes, of course. What you're seeing is where the attacks are starting, where they're aimed at, because as you can imagine, the attacks need to be handled as close to the source of the attack as possible, because if not, then the outcome becomes really bad. We want to be able to keep that malicious traffic off of our networks.
It's pretty interesting. Where are the most attacks coming from right
my
now?
next question. Where's most of them originating
So
from?
many of them are originating from places where we all do business, Tim, which is really interesting. We
Like
see
the
them.
US?
Yes, from the U.S., from some from Africa, some from places that you may expect or may not expect, but they're all over the world, David. So when you think about it, it's not only the attacks, but what the attacks are. They're kind of like me. They have multiple personalities. They change every minute. They change. So we have to be able to evolve and to be able to deal with these attacks at scale. So
The app is available to anybody. So if we put the link in, they can look in and see what's going on in DDoS
I'm
world
glad
today.
you said that. So I'll put the link below so anyone can go and see this in real time live, right?
yeah, livethreatmap.radware.com. Not hard.
Brilliant.
And you can, no subscription or anything required. You could required. You see the top attackers, you see top ports, top services, who's doing it, what the targets are, and what kinds of attacks there are. Interestingly enough, Cisco and Radware work together a lot on our threat intelligence. It's something that Tim's organization and mine.
Tim, you're with Cisco, right?
I'm with Cisco, right? We have actually the largest private threat intelligence with our Talos group.
Yeah. Those guys
out
are great.
there. They're amazing. Beers with Talos. I don't know if you ever seen that.
Yeah.
But the partnership together, sharing that data, getting more enriched information from the Radware products, from the Cisco products, and continuing to share that. That's one of the things we do in the cyber community, though. Even with our competitors, we share this intel data to make sure we keep everybody safe.
Yeah, exactly. I mean, companies are not the enemies. The enemies are the attackers. Yeah, I wanted to ask you, sorry to interrupt you, like somewhere there, I want to know, like, what are the top types of attacks?
Scanning is a prevalent attack and has been for the last
Like
30 years, right?
Type thing.
Yeah, that hasn't changed. Looking at Web DDoS-based attacks. So this is a new modality of DDoS that builds on the traditional layer 3, layer 4, which we see everywhere. But now we're abusing layer 7 parameters, cookies, sessions. The attacks are encrypted. And you look at it and you say, well, okay, that's a Russo-Ukrainian conflict thing. But you know what? In campaigns like KillNet and others, in the enterprises that we take care of, that Tim's team and mine take care of together, finance, universities, healthcare, critical infrastructure are all kind of now destinations and targets of these, whether it's for political or monetary or nation state benefit, whatever the case may be.
You mentioned the layer 7 attacks. Can you just give us a bit more information about like the weird attacks that are happening today? Because you said like new types of traffic is being sent.
Sure. And they were weird a year ago. They're not so weird anymore.
Yeah.
So they've started to become commonplace. So what happened was when the Russo-Ukrainian conflict started, well-funded nation states are capable of doing very powerful things.
Exactly.
Well, they changed the game in DDoS from utilizing just layer 3, layer 4 oriented, volumetric and low and slow oriented attacks to a new modality, which involves these Web DDoS attacks, which are HTTPS driven.
Yeah.
So they're encrypted.
Yeah.
Right. So you need the computational capability in the cloud to be able to deal with that. That's kind of why we do it that way. But what happens is then there are these dynamic signatures and patterns that come about as a result of this, where the ability to diagnose those DDoS attacks as they happen this way becomes very important. So to answer your question, yes, they start on the HTTPS side, but they are very much multi-protocol events. You could have a volumetric extraction followed by a DNS-oriented query flood. And we all know what happens if DNS stops working, right?
So what is DNS?
Voice doesn't work, web doesn't work. It becomes a very easy target. And so even if you look at the map and you see the genesis of where these Web DDoS attacks are happening, it's not just from the places that we're mentioning. So the ability then to dig in and have an Anycast-driven DDoS cloud of 21 terabits of capacity. Yeah, the number kind of doesn't matter, but it's the ability to scale to deal with these attacks, to have the technological agility and understanding to correlate these things together. So the Web DDoS attacks, yes, are HTTPS, they're encrypted. They are abusing layer 7 parameters, however, which is different because they're using session hijacking, they're using other cookies, other methods that typically didn't come in this domain. So you have this attack range that sort of sits just a smidge outside of what a WAF does, and just a smidge outside of what DDoS traditionally does, and it becomes a very rich target because of it. And there's some very rich, programs that have come about. KillNet's a good example of one that utilize this attack mechanism. It's really a challenge, David, that we're dealing with in real time this way. Because you look organizationally. It's interesting. We're talking technical, but you look organizationally. You usually have an application security group, and a network security group, and often in the largest organizations, these meet at the top somewhere in the SOC or whatever. But in many medium-sized and downstream enterprises and even carriers struggle with this, and so this is really what the dynamic of Web DDoS.
You mentioned
is.
carrier too, right? And just think of it's not new anymore. 5G we're moving on, but just think of the packet core, right? They changed the architecture. How do the communications happen between the containers within there, and how do you protect and validate that information, right? And that's where these products like the WAF come into play, right? Where they can make sure and validate the communications that's happening within a core that could take down all of your mobile devices, right? Out there.
Yep.
Well, closed architecture before, we didn't have to worry about that. Now we have to worry about that. Right?
Well, it's interesting because in the packet core, in the 5G standalone packet core architecture, you have really a couple of components where security really it comes into play. One is on what Tim's talking about in what we call the SBA. There's a mesh of network functions now that you can actually buy from different vendors, and you become the integrator. Well, how do you now know that those APIs are doing what they're supposed to? How do you know that those applications and functions are behaving the way they're supposed to? What we did is we built a Kubernetes native application control. Remember I mentioned before that the technology is born in the cloud and delivered in wherever the customer needs it. Well, in this case, we're able to run exactly in the Kubernetes pod. Works the same for non-5G outcomes, for any cloud native outcome. And now we're able to have a control plane and an enforcer that will go in and deliver that inside. So now
Open RAN environment.
So now those those network functions now that live in the packet core then will now start to serve much more securely what will open, the RAN, the N3 and kind of the access, but the link between the radio and the packet core, inspecting things like GTP and finding rogue UEs. It's interesting to find out. And there's there's a lot of old technology here, David, but there's a glut of new technology that we bring to make this real. Taking a bad user off a mobile network is not a new thing, but being able to do it based on tunnel endpoint identifier and being able to now move that out into the Open RAN architecture, the interfaces change. So there's a lot of very interesting outcomes when you start to get into the Kubernetes space and the cloud native space, where this security kind of becomes layered and defense in depth. And Tim, I think this is an area where the Cisco technology and the Radware partnership with it really pay off.
Yeah, you look at, and that's also bringing in, the edge product that we talked about before, right? How do we put that out at the radio, right? At the tower, and make sure that way you've got clean data within our internal network and stopping them.
Or on the internet breakout on the N6 or the whichever place in the network it is. The mobile architecture is very fascinating, David, because it's a model that has changed significantly lately, but really hasn't changed very much. Technology evolves, it gets faster, it gets more agile in cloud native delivery. Internet breakout goes from a central pipe in 4G to widely distributed. So you think about it.
That's the thing, though.
Yeah.
So from building these all together, enclosed, very secure because nothing's going to touch them, to scale and get to where we need to go, it all becomes distributed now. And then there has to be communications between there. And a lot of people forget about protecting those communications, right? So that's where it happens. You got to scale, you need to add security on. So security, I always think about it as you can't have a fast car unless you have brakes on it, right?
Good point.
So you can't build a fast system unless you have security on it to make sure that it'll stop when it's needed.
So look, with the packet core is a good example of an evolution towards and the pervasive nature of why our partnership is really so important, which is that these 5G outcomes in the packet core, okay, there are a number of us nerdy kind of guys that really like that kind of stuff. I'm one of those, and so is Tim. But when we think about it, private 5G is a real thing. So now what does that mean? That means that the consumers of this technology and the need to, in an agile way, push security out to the edge to protect these enterprises and now the 5G outcomes that deliver connectivity and services to those enterprises now connects the dots.
Yeah.
So now what are you talking about? Now you're talking about secure access for the enterprise. You're talking about protecting that 5G presence on their prem. You're talking about protecting the API to API interfaces and applications that need to interact with the packet core to deliver private, secure outcomes. So all of a sudden, this new, what was this kind of carrier-focused, very niche-focused conversation, David, now comes to every enterprise and downstream. I mean,
healthcare. Think about healthcare, right?
Absolutely.
So what are they doing, right? You start out with they're kind of running their ped meds or their, all of their automated equipment. But now you can get a colonoscopy and you can send it down right to your private 5G, and you don't have to worry about a doctor misreading it, and they'll come back and they'll tell you, what's going on. So you need that ability to to protect that environment because it's running critical infrastructure, as we were talking about before.
I wanted to ask you some concrete examples. Have you got some like real world examples of like perhaps where enterprises or healthcare or whatever it is, service providers have been like hit with a massive attack and like how you protected them?
Yeah, so there's a few. So I'll talk about a large hospital. Again, we'll keep the people's names out to protect the innocent. But that KillNet campaign directly targeted healthcare. And what we actually found is that I'll tell you how it happened from the beginning. So they called their Cisco representative and said, "Hey, we're under attack." Okay.
How did they know they were under attack? Just like the systems were going down, or
devices were compromised, everything was really slow.
Okay.
And in certain cases, this was not one of them, but in certain cases, they even get ransom demands, David.
Yeah.
So but there are very specific guardrails that HIPAA puts in place, and they were far, in excess of those. So what ended up happening is we worked together and we have an emergency onboard service. So whether the person is a customer or not, we bring them on, we help them get out of hot water, which we did. The nature of the attack was widely distributed. It was coming not unidirectional. It was coming from an army of bots all over the world. And we had to leverage our size and scale to be able to help mitigate those. And so it was done in an emergency basis. But technically, the nature of the attack was it started with saturation of the pipes that fed the hospital. So volumetrically, there was a whole bunch of, let's just say, malicious junk that came and made it so that any traffic that was going through those pipes or any services that were being consumed, if Tim were checking his healthcare to his example earlier, and he needed to go and run an application, those applications were also being hit very hard. So everything was grossly slow, unresponsive, and customer sat and in this case healthcare was people's healthcare and the ability to exercise around it, patient medical records, pharmacy, all these things were highly brought into question from an integrity perspective. So
but I'll tell you what, though, about the one thing you've glossed over a little bit, and this is where I love the partnership with us. So we have a Cisco customer not buying not a Radware at this point in time, calling up saying, "I don't know what to do."
Yep.
We're able to work together. Our organizations, both from the sales side and engineering side, are aligned together. Just forget about selling anybody anything, whatever. Let's go address it and take care of it. They were able to throw whatever was needed to go out and stop and help get this hospital back up.
Indeed. Absolutely.
And, that's just great, right? So
it's so important, right?
Yeah, with no expectations at the end, it's like, let's go out and help this out there.
The technical debt that we bring, the technical capabilities we bring with us just totally, completely got them out of hot water, got them back online. And in this case, the actual distribution technically was a bunch of volumetric different attacks, things like SYN floods and DNS floods and this and that. And they worked their way up into some of these layer 7 abuses, which is interesting because the way that the layer 7 stuff works is it's high densities of requests per second, not bits or packets per second, that get targeted at specific assets, origin servers or some specific target that either they know about or that's been discovered. So, it's interesting, David, when you think about how it breaks down, that the businesses need to have a safety net underneath them. I mean, I hate to sound like too much of a salesy guy, but it's true. The way that this example with the hospital worked out, people's lives were saved.
I got to ask you, what kind of devices are being used to launch attacks? You mentioned cameras, but what are you seeing of what kinds of devices are getting compromised or used to launch these attacks?
They're coming from
refrigerators,
everywhere. Yeah, exactly.
Yeah.
The most eye-opening is just because people don't expect it.
Yeah.
Are what Tim correctly calls IoT devices. So things like how often do you think about the internet access that's in your refrigerator?
Yeah.
Yeah, and the password's always the same. It's default, right? So everybody knows it, and you can go put it on thousands of these devices, right?
Like fridges.
Yeah.
Yeah, a fridge, a microwave, your car.
Oh, attacks are being launched from cars.
The communication systems in cars is a broadcast medium across the backbone of the different systems in the car.
We're working with a couple of large car manufacturers, specifically over in Europe right now, building in the firewalls into these electric cars and into these new cars. So then you think about, okay, now I got a firewall. We just talked about, do you put a firewall in without DDoS? So you got to make sure that the environment that they're working on can do that, because you DDoS a car.
You think about that model. Cars is one, cruise ships is another one.
So attacks are being launched from the cars, right, and from cruise ships. Is that what you're saying?
When they're compromised, yes,
Yeah.
at times
So they use that to launch.
more cars. So think IoT devices, things like cars that are easily programmed. I mean, if I sent you a USB key and said, plug this into your car just to update the map, would you even think twice about plugging that USB
I would,
key in?
but I know a lot of
Many
non-technical people wouldn't.
Right. Okay. Maybe that's fair. That's the whole point. You know, it's not hard to get these things distributed. I mean, that's kind of how Stuxnet happened. One of the most famous. And that USB key got put in what? In a nuclear reactor. Okay. So you can, but those attacks have, there is an economy now around, and it's that easy to be able to download code to run bots from wherever you darn well please, from a, you know, from an EC2 instance in Amazon, from your own PC, from from whatever can be infected, and shut off via command and control, and some are self-contained, and but if you look at the stack of security services that Cisco and Radware have together, you think many of them who use DNS will be protected through the umbrella recursive DNS security capability as part of secure access now. Many of them will be detected as part of our bot service. We will be able to look at different modalities of how they execute and run it that way, David. So it is a defense in depth game that we play. But yeah, these bots can be launched in it's kindergarten math to take over for today to run these things.
So hold on a minute. Cars in the past, right, were like analog devices, but obviously with electric cars, I'm assuming this is becoming more and more of a problem.
100%. It's and you know what? To tell you the truth, the car manufacturers came to us, right? So how do we make sure that we're protecting this environment, and then how do we build a unique form factor or software-based solution that'll go in from a firewalling standpoint, right? To protect that from either becoming an active shooter or an active device out there, or from somebody taking over that car and being malicious in another manner where he could kill
Tim,
a person
recently,
on the
how
road.
many times at Black Hat have we seen demos that took over? I'll leave the brand of the car out; it doesn't matter.
Yeah.
But that took over an electric car and made it brake and made it turn and made it do it's a constant back and forth, David, I think, from a security perspective. But
as everything evolves, right? As everything evolves, it has to get go to that next level, faster, better. That introduces more complications for security. You think about that, right? I'm going to have a firewall in my car. It's kind of weird, right? Kind of strange. But if you don't have a firewall in your car, you probably don't want to be in that car in another 2 years, right? So it's going to be an important part of buying decisions.
I mean, it's amazing with IoT and like how more and more devices are being connected to the internet. So it sounds like a good idea. But from the bot point of view, it sounds like a nightmare because just more and more devices that can be controlled to launch these attacks.
Well, and these devices, David, are not built with security in mind. They're very low cost, and candidly, you can go out on the internet and run a search and get, to Tim's point earlier, to get the default password for any of these devices and be right 99.5% of the time, because nobody ever changes stuff.
And most everybody has a little talking box in their there's a young lady in there, and then all of a sudden they say, hey, do you want to communicate with your neighborhoods and stuff like this, right? And now you've created this open environment where now, it's almost like doing an acquisition or having suppliers, right? You got to make sure your neighbors secure and that kind of stuff. So when you look at how simple it is to bring these new devices up, you really you got to think about security across the board in there, because those are the guys that, and once again, when you talk about botnet and those attacks, they can get into millions of those devices and use them as an attack surface. And it depends, right? If really low cost IoT devices, but if they have enough space where we can kick off scripts and run from there. And some of the high costs are built, differently, and those are tough to take over in there. So it's kind of like, we don't always want to buy the cheapest stuff. We want to make sure we buy the securest stuff that's out there going on. But yeah, I think it's crazy. In cameras is like pretty much a number one thing that's out there in the environment.
I mean, you go out and what's the solution? So if that, let's say that camera is known to be a bot. Okay, fine. So we figure it out and we find out that it's compromised. What do? You flash it, and it now has a fresh configuration with the same default password, and then the exact same thing is going to happen 5 minutes later. The other thing to remember is that the barrier to entry for DDoS used to be kind of high. You sort of had to know what you were doing. These days, you can go out to Git and download and download the code. As a matter of fact, you can go to ChatGPT or whatever your favorite. I don't want to pick on them, but your favorite AI chatbot that you use, whichever flavor you use, and ask it to build you malware.
That's excellent.
Now, is it perfect every time? No, but it's learning.
Doesn't have to be. Yeah.
And any published CVE that you can go out there, you can say, give me an exploit for this CVE. They write the code. And then what do? If it's a widely deployed device, now I can go after that thousands of devices out there.
You made me think of something. So, there's a very well-known set of security tools that runs on Linux called Kali Linux.
Yep.
Kali Linux now features an AI-based enhanced tool for training, and it also uses that tool to help you. So you can now go into Metasploit instead of having to know how to run something in Venom and get it done and and execute it and download it and deploy it and reverse shell and this and that and the other. Now you can go to the chatbot and say, okay, I need a vulnerability an exploit that takes advantage of XYZ vulnerability, to your point, and I want to deploy it on Windows and Linux. So open me a shell across these different devices that I know of, and just go do it. It doesn't take any brain power to do it anymore, David. It really doesn't.
The barrier to entry to building your own botnet is much lower than it used to be.
Indeed.
And there are more and more devices out there that can be attacked or used as part of the botnet. And this is why we need solutions like what Cisco and Radware are doing.
Script kiddies now can do things that you used to have to be a nation state to do before, with nation state funded, high capital investment in people and markets and technology and things. So much of that is out there to be done now. And if you don't want to do it yourself, there's a whole economy now where you could go to buy it on the dark web.
I was just going to say, just like, some of these new Gen AI tools have made me a really good writer.
Well, exactly.
They can make attackers really good attackers. Right?
Yes, and really bad ones.
So
too.
If they're a bad attacker, they can become good, like me in writing. So it's kind of like, and at scale. So that's the scary part, right? So we're taking this great technology, and we just got to always be careful because it simplifies the attacker's world and allows them to scale much quicker than ever before. The reason this partnership is together is the Radware has the expertise in this area, and they have the agility to continue to evolve quicker than if we kind of put these products out ourselves. So we figured out, how do they fill the gaps, whether it's with cloud native based security solutions, protecting your apps out there, or whether it's with DDoS. And then how do we just build it in as one cohesive solution? So the partnership is more of an OEM where you think you're buying Cisco SKUs, at some time you're buying Radware solutions out there. And we help each other. We kind of scale the sales force out there and have that capability to make sure that Radware is positioning Cisco and Cisco is positioning Radware. So the better together, I think G2 says 1 + 1 is 11.
Yep.
Not 3. It's 11.
Yep. Can you give us some examples? Like, is Radware in like the routers? Is it in firewalls?
Yeah, I think one of the biggest areas we talk about edge. You want to talk about
Sure. So we are in we are in it. So we like to say our technology is born in the cloud and offer in whatever modality the customer needs.
Okay.
There are certain types of attacks that we will run, very high volume, large scale, that really need to run through cloud. And some of these Web DDoS attacks also kind of beg for the size and scale computational capability that's available using a cloud. But there are certain types of attacks that are better exercised by a hybrid solution where you have an appliance or a virtual machine on premise that combines with the cloud and then arrives at a conclusion where you can protect both ends. It's kind of like having a security guard at both ends of the hallway. Now, we also, though, have customers that are looking at the edge, either the enterprise WAN edge, the service provider peering edge, or any of even the new edges in cloud-native application development, where they say, listen, I'd like to run inside of a container, inside of a router. And we do that as well. So, these are the different modalities of DDoS and application security that we're able to provide. And another interesting technical aspect of that, David, is that for the application side, many times customers say, yeah, well, I've got special conditions that mean, because of regulatory pressure or otherwise, that mean that I need to go and be able to use my local enforcement, but I want to use your agility, to Tim's point, and security capabilities, your application security in the cloud. So we have a deployment methodology that we do together called Secure Path.
Okay.
And that allows me to use my on-premise capabilities, maybe where I don't want to share a certificate up northbound, and I can use the depth and breadth of the API security, the application security, botnet protection, all these kinds of things from the cloud, and have a best of both worlds. So, I guess, Tim, if you think about it,
Okay. So,
you combine that with what we do. For example, here's a great real world example for you,
I love
David.
stories, so give us examples.
Anytime you deploy a firewall, wherever it is, and this is not a firepower firewall Cisco problem, it is a firewalling problem. Firewalls are bound by state tables. And under attacks, those state tables fill up and the firewall has a dysfunction problem.
Yep.
So one of the things we do together is we've positioned a stateless DDoS capability outside of the firewall as a buffer zone.
So is that internal in the firewall? When you say it's outside the firewall, is it a separate appliance or?
Often some customers, Tim, will choose to deploy in the cloud to protect the pipe that feeds the enterprise or the service provider. Some will deploy on the prem, like you asked. We started the partnership in the firewall with an integration in the firewall.
With an integration in the
Yes.
firewall, but it made a little bit more sense, I think, when we see some of the applications as you continue to grow the business in the cloud area, right? So stopping it before it gets into here, like as further back that we can, stop and negate attacks is the best. But if you think about it, like there should be a natural buying motion. If you're putting a firewall at the edge, you better have DDoS support around that, because that is the most vulnerable thing that's going to be out there.
We were talking offline about, I could put a big firewall. I think let me say it this way. I think there's a misconception that if I put a big firewall on the edge of my network, I'm fine. But you said something like not a lot of traffic can bring down a firewall, right?
It can. It doesn't take a super high volume attack to fill the state table of a firewall.
Yeah.
It's a fact. It's not a Cisco problem. It's a firewalling problem. When many of these firewalls were designed and deployed, the attack kind of frequency and depth and breadth wasn't what it is now. So yes, this is something that we do. And for the same way that we play in the firewall that way together, then you move it over, firewalling is now becoming, if I'm sure all the folks at Cisco Live, Tim, have heard a lot about Hypershield and our ability to put policy around on DPUs, around switch ports and routers and other devices.
Yep.
And to keep that's sort of now the dream, to have a firewall in every capability in every port. Well, wouldn't it be interesting now if you turned around and you said, well, all right, I now want to bring proper security to that distributed firewall capability in terms of a safety net to keep it alive. Number one. Number two, then you go out and you say, well, many of Cisco's largest enterprise customers, Tim, are by the Cisco Secure Access Service.
You think about that with the web application firewall, right?
Sorry to just interrupt you about that. What is a WAF? Perhaps you can just explain it in a bit of detail, and then like how does it actually work in the real world?
Think about WAF. It's a web application firewall, right?
Okay.
So how do we make sure we're inspecting what's going to and coming back from, and can be used in both a forward and reverse proxy manner,
right?
As you deploy it out into the environments. And one area that we see with our secure access or any type of like, cloud-based, security-based solution, SSE-based solutions out there, you got to protect the traffic going both ways and then the communications within there. So if you want to talk a little bit about like what we're driving together from a use case and implementing WAF into the SSE.
Absolutely. So the SSE or secure access modality of security that Cisco offers and is an outcome partially of the forward proxy capability that came from the OpenDNS or Umbrella acquisition.
Okay.
And what ends up happening is that the forward proxy protects known users, apps, and devices.
Okay.
Well, what the partnership brings is that Radware bring to the partnership, as Tim was mentioning, the other direction. So we offer what's called a reverse proxy. So we're protecting apps that sit in a DMZ or out in the internet from threats such as the web application firewall handles, for example, OWASP top 10 threats. Well, things like SQL injection. But the important thing there is that the result of the partnership technically brings us a machine learning-led capability so that there's ability to look at the behavior of the application and what's normal and what's not normal. Because most web application firewalls today are really beholden to thresholds.
Yeah.
Yep.
And, the best analogy I can give you technically on a threshold-based, kind of approach, David, would be if I drew a threshold and said 500 megabits of this specific traffic is a problem.
Yeah.
Okay. How do you know the difference between a flash crowd and a DDoS attack?
Yeah.
You don't. So you need to understand the behavior. And this is pervasive technically across the web application and API protection that we partner on together that joins with secure access to make what I would argue is a better security gateway. So we talked about what web application firewall does, but then there's API security. So you need to look at...
I'm glad you mentioned that.
Yeah. You need to look at transactional integrity across the API, number one. But that's kind of the shallow end of the pool. The deeper end of the pool, the more complex, is Tim abused API endpoint X, IY, and UZ. And those three things in this sequence are not normal. And these things look a lot like an intent of data exfiltration. Okay. So you're starting to see a machine learning-led technical bent to the application security capabilities in WAF, in API protection, and same for bot management, which is the next component of the application security technically. So you look at what bots are 85% of the traffic on the internet today. There are good bots and there are bad bots. Well, how on God's creation do you know the difference?
Exactly.
Well, you need to be able to look at intent because, Tim, the really interesting thing about bot traffic, first of all, it comes from everywhere you do business. Amazon, Google, Microsoft, my private cloud, your private cloud, his enterprise, whatever. So the thing of it becomes, how do you tell the difference between a good bot and a bad bot? You're looking at intent. And to look at intent, you have to have a machine learning-led capability, which we do, that handles this responsibility. But that's not enough. Many bots, you remember Mirai botnet, for example, many bots take over very small devices. Mirai botnet was on IP video cameras, if you remember back in the day. Okay, so wouldn't it be cool if you could use a crypto challenge algorithm to make those devices so busy that they can't attack you anymore?
That's clever.
And that's what we do that. So all of that is cool.
It's called fighting back.
Yeah, man. Absolutely. It's called fighting back. And all of that is cool. The layer 7 DDoS stuff we talked about earlier is part of it. But this is all kind of origin server side. You can imagine that to protect an application, There's the client and there's the server. Okay, that's not new.
No.
But the regulatory bodies, PCI, HIPAA, and others, now force us to have a control that on the supply chain, the software supply chain on the browser side, to make sure that those JavaScript libraries are not being brought from nefarious places and they're not doing nefarious things. So if you look across all of these modalities of security, David, the poor sock and knock people that have to monitor events for all of those different things, and then for secure access, and then maybe for hypershield and whatever. So there's a big problem of a glut of information. So we've built an AI-based inference engine with a chatbot that can be queried to basically bring all of this better correlated, better together into play. And maybe, Tim, it makes sense to talk a little bit about secure cloud control, what you're doing on the threat intel side, because it's kind of a very similar thought process and approach. No?
That's the one, there's always this discussion out there. Yeah, do I do best of breed in my security world? Do I do platform in my security world? I kind of feel like you have to do platform and best of breed to get out there, because if you have to wait on somebody to plug a hole and they don't make it, then you're in trouble, right? So what we're looking at, and a lot of different companies are looking at, is instead of these closed systems, how do we open up systems more to integrate with a common policy that goes across multi-vendor environments, right? So we set a policy. We know HR can't talk to these servers on the weekends or something like that, and having that capability to normalize that, and even take agentic AI. That's where we are right now.
Right? That's my next question.
So you take those agents for each one of the different vendors that are out there, and then you have a controlling agent that helps pass this information down. And you've created an environment where you have a platform where you're simplifying the way you manage and you look at everything, but you also have the capability to use the product that you feel fits best where you need it. So, we call ours Security Cloud Control, and we're continuing to evolve that and open up. We just announced the ability to work with Fortinet, with Palo Alto, and a couple other vendors that I forget out there. But that's just going to continue to grow out there. So platform plus best of breed is really where I think, we are.
Any final thoughts before we wrap this up?
Yeah. So look, Tim, I think when we started this whole thing, we looked at the threat surface that's out there. We looked at the advanced threats that are coming toward our customers together. And what we've come to find is that where there is a need to protect not only the critical applications that run our daily lives, but the networks that deliver them. And this is, David, kind of what we do together with Cisco and Radware. We've talked a little bit today about some of the advanced technology aspects of this and some of the business side needs of it. But in the end, you need to be able to comprehensively provide a safety blanket to these critical apps and services that run in that we depend on in our lives. And this is what Cisco and Radware do together.
You always hear about the traditional IT security that's being implemented, right? The endpoint security, the firewalls, CNAP, cloud, all that kind of stuff. And I think DDoS it's an afterthought, right? And then when somebody gets hit with it, now it's top of mind. So I think what have to look at when you're designing a complete end-to-end security solution, you really got to start thinking about DDoS, because it's becoming so much easier for the bad guys to go launch an effective attack. Appreciate the partnership. It's really good. Thank you.
Guys, thanks so much.
Thank you,
That was
David.
brilliant. Thank you.